The Type 815A intelligence vessel. Tianwangxing had been loitering at the edge of the exercise area for 6 hours before anyone on its bridge noticed that the American fleet had stopped transmitting. Not stopped moving. The surface radar returns were still there. The geometric wakes, the hull contacts, the formation geometry. But the electromagnetic spectrum, which 30 minutes earlier had been saturated with the characteristic emissions of an Aegis battle group running active air defense operations, had gone completely silent. No SPY-6 search sweeps, no fire control illuminations, no Link 16 burst emissions, no navigation radar, no communications traffic on any monitored frequency. To the Tianwangxing's collection operators, an American carrier strike group had just ceased to exist electronically while remaining physically present on their radar displays. Understanding why this mattered requires understanding what the Type 815A was actually there to collect. The ship is not a combat vessel in any meaningful sense. Its 4,000-ton hull carries no offensive weapon system of consequence. What it carries is collection capacity. An array of passive receivers covering a broad frequency range, a signals analysis suite capable of characterizing and cataloging radar emissions in real time, and the processing architecture to build what Chinese naval intelligence calls an electronic order of battle profile. A comprehensive library of every system a target fleet is running, at what frequencies, with what waveform characteristics, and with what operational behavior patterns. That library is the precursor to every Chinese anti-ship and electronic warfare system's targeting algorithm. Without it, those systems are firing into an electromagnetic void. With it, they know which frequencies to jam, which signatures to track, and which deception modes will produce useful results against specific American sensors. The Tianwangxing had arrived near Guam specifically because the USS Theodore Roosevelt Strike Group was running its large-scale integration exercise, the kind of high-tempo, multi-platform operation that forces every sensor in the formation to run at maximum output and produces the densest, most operationally representative emissions picture a collection ship can hope to record. The timing was deliberate. The positioning was deliberate. The question of whether the Americans knew the Tianwangxing was one the ship's captain had assessed as irrelevant, because international maritime law permitted the vessel to operate in international waters, and American doctrine did not permit firing on ships that were doing nothing more than listening. The captain's assessment was operationally correct on every point except one. He had assumed the American fleet would continue transmitting. The command that went through the Roosevelt's Combat Information Center was brief. The duty officer announced condition MCON, and the ship's electronic management architecture executed the shutdown sequence it had been designed and rehearsed for. Every active emitter on the Roosevelt and across the associated destroyer and cruiser screen went to standby or passive mode in a coordinated sequence that took under 90 seconds. The strike group was still physically present. Its radars were still operational in receive mode. Its weapon systems were still ready. But its electromagnetic profile had dropped to nearly zero. The environmental conditions that morning had been factored into the timing of the MCON execution. The operational area near Guam carries a specific atmospheric geography that experienced Pacific Fleet navigators and electronic warfare officers understand in detail. A thermal inversion layer that morning was bending surface-propagated radar waves in a way that caused large surface contacts to appear as smaller returns at the distances the Tianwangxing was operating from. The low humidity layer above the inversion scattered infrared sensor returns. Sea State was producing a confused wake pattern across the formation that undermined the satellite-based ship tracking algorithms that use wake geometry as a primary identification feature. The Americans had not created these conditions. They had waited for them and then turned off the lights. From the Tianwangxing's collection console, the picture went from extraordinarily productive to completely empty in under 2 minutes. The operator's immediate assumption that the American systems had identified the collection operation and shifted to a protected emission mode was directionally correct, but missed the more significant implication. Not that the Americans had changed frequencies, but that they had stopped transmitting entirely, rendering the collection mission structurally impossible regardless of what frequencies the Tianwangxing's receivers were monitoring. Beijing's contingency for a denial of collection scenario was already taxiing at a coastal airfield before the MCON order had finished propagating through the strike group. The WZ-7 Soaring Dragon high-altitude reconnaissance drone launched at 0840 and began its climb toward its operational ceiling, a tandem-wing platform optimized for sustained flight at altitudes where its synthetic aperture radar and electro-optical sensors can survey maritime areas measured in thousands of square kilometers. At 60,000 feet, it is above most weather systems that degrade optical observation, above the infrared sensor noise that surface humidity produces, and high enough that its own radar can look down through the cloud deck that was blocking the Tianwangxing's line of sight. The WZ-7's SAR does not depend on the target emitting anything. It generates its own radar illumination, processes the returns, and builds a surface picture regardless of whether the ships below are running their own radars. The MCON posture that had denied the Tianwangxing its collection product was not a defense against a radar that could see without being seen. The Japan Maritime Self-Defense Force P-3C Orion that was on its assigned patrol track 110 kilometers to the northeast had detected the WZ-7 11 minutes before it reached its survey position. The P-3C's APS-134 radar had resolved the high-altitude contact against the background clutter, classified it by altitude and flight profile as consistent with a high-endurance reconnaissance drone, and transmitted the track data into the Link 16 network that connected Japanese maritime patrol aviation with the Roosevelt's Combat Information Center. The track appeared on the American displays without the American ships having emitted anything to generate it. An ally sensor, operating on its own national mission with its own national radar, had produced the datum that the collection ship's operators most needed to remain undetected, and had provided it directly to the force the drone was surveilling. This is the specific asymmetry that the Chinese operational planning had not fully accounted for. The collection architecture they were running required the American fleet to generate emissions, and the surveillance architecture they were running required the American fleet to either not know it was being surveilled or to have no sensor in the vicinity that could detect the drone. Both requirements failed simultaneously because the American force included allied assets whose sensor activity was not visible to Chinese electronic intelligence collection and whose data sharing occurred in encrypted channels that the Tianwangxing's receivers were not configured to monitor. The Tianwangxing's captain, knowing his primary collection mission had been denied, but unaware that his drone had already been detected and tracked for 11 minutes, authorized a decoy probe. The ship deployed a small radar-reflective expendable buoy designed to simulate a contact large enough to prompt an American radar system to illuminate it. The logic was sound. If the American fleet was maintaining MCON because they were aware of the collection ship, a false contact might generate an impulsive radar interrogation from an operator who had not received or retained the MCON discipline briefing. No American system responded. The decoy drifted and eventually sank. The silence was absolute and professionally maintained. Two EA-18G Growlers launched from the Roosevelt's flight deck at 0917 hours. Their departure from the carrier was not a response to the decoy. The collection record from the Japanese P-3C and the Roosevelt's own passive receivers had already built a comprehensive picture of the Tianwangxing's emission profile, its operating frequencies, and the specific radar mode the WZ-7 was using for its synthetic aperture survey runs. The Growlers launched because the intelligence package was sufficient to begin the second phase of the engagement. The AN/ALQ-218 tactical jamming receiver that each Growler carries is, in its passive mode, one of the most sensitive electronic collection systems in the American inventory. It can characterize a radar emitter's waveform in seconds and build a jamming response optimized for that specific emitter's signal structure. The ALQ-218 had been passively collecting the Tianwangxing's own collection suite emissions since the ship had first arrived on station. The Growlers were not flying toward an unknown target. They were flying toward a target whose electronic signature had been fully cataloged. The AN/ALQ-99 jamming pods activated at a range calculated to maximize the geometric spread of the interference pattern across both the Tianwangxing's antenna array and the WZ-7's ground data link frequency. What the Chinese collection operators saw on their displays was not simple noise. Their screens populated with coherent, structured contacts that had the radar signature characteristics of multiple carrier strike groups appearing simultaneously on widely separated bearings. The signals were not random. They were crafted from the emission profiles the ALQ-218 had collected from the American formation's own prior transmissions and repackaged into convincing false pictures. The Tianwangxing's operators were now receiving an internally consistent but factually false picture of the operational area. The systems generating those returns were operating from an altitude and geometry that the Type 815A's own receivers could not localize. The Growlers were using the ionospheric conditions that the Roosevelt's operations team had specifically identified as favorable for signal scattering, bouncing their jamming energy off the inversion layer in patterns that made directional triangulation of the jamming source unreliable. While the Tianwangxing's crew was working through the false picture, a P-8A Poseidon descended out of the cloud deck at low altitude directly over the Chinese vessel. The P-8A's cameras and sensors operated in full active mode, documenting the ship's hull markings, antenna configuration, equipment on deck, and operational posture. The collection was comprehensive and legally unimpeachable. International maritime law permits the same overflight of vessels in international waters that the Tianwangxing had been using to justify its own operation. The message was delivered without a single word transmitted on any monitored frequency. The Chinese vessel had been observed, the observation had been documented. The mission was over. The Tianwangxing increased to transit speed and departed the area. The WZ-7 climbed to its return profile and headed for its recovery base. The false carrier strike groups on the Chinese collection screens evaporated as the Growlers secured their jamming systems and returned to the Roosevelt's recovery pattern. The intelligence accounting at the end of this engagement requires precision to be useful. China's collection mission produced nothing from the period after MCON was activated. Approximately 2.5 hours of operational time, during which the Type 815A's receivers recorded a flat electromagnetic environment from the American formation. The WZ-7 synthetic aperture radar imagery was degraded by the jamming geometry during its most productive survey window. The collection data that was obtained before MCON activation was the most valuable portion of the mission, which is why the timing of the MCON call and the environmental conditions under which it was executed was the decisive operational decision of the entire engagement. The American side added to its Tianwangxing hull profile, confirmed the WZ-7's operational ceiling and SAR operating frequency band, characterized the Type 815A's collection suite emission behavior under a denial scenario, and obtained an updated visual and electronic documentation package on the ship's current antenna and sensor configuration. All of this was collected passively or through legal overflight. None of it required the American fleet to emit anything that could be turned against them. The sea near Guam looks the same the following morning, regardless of what happened during the night. The Roosevelt's flight operations resumed on schedule. The Tianwangxing returned to its home port. The WZ-7 landed and underwent its post-mission data download. What had changed was invisible to any external observer and entirely visible to the analysts on both sides who were processing the engagement record. One side had built on what it already knew, and the other side had come to collect and left with nothing. Here is the question that points toward the next iteration of this competition. The MCON posture that denied the Tianwangxing its collection product is effective precisely because it is a choice. The American fleet can operate silently when it needs to and actively when it chooses to. But a fleet that cannot use its active sensors for extended periods to avoid detection is also a fleet with a degraded picture of its own operational environment during those periods. As Chinese satellite constellations, high-altitude drone persistence, and multi-static passive radar networks become denser and more capable, the window during which MCON provides meaningful coverage against persistent surveillance shrinks. At what point does the asymmetry between the cost of going silent and the degradation of the force's own situational awareness start to favor the collector rather than the evader? And what does the American answer to that question look like architecturally? Leave your assessment below.